Right, guys, today we're going to go through making salts from acids. So specifically looking at how metals react with acids. We did briefly touch on this in part 1, but we're going to go into a lot more detail today. So for this, the first thing we need to do is refer back to our reactivity series, okay? Now, essentially, any metal that is more reactive than hydrogen will react with an acid and form a salt, a metal salt, and hydrogen gas. Okay, so the salt formed is an ionic compound, and the hydrogen essentially just disperses off the top as a flammable gas. So this is quite a common reaction in the manufacture of different salts. So let's just look at the 3 acids that you need to know about. Again, we have covered this before. If the acid is hydrochloric acid, then the salt formed would be a chloride. So if we look at the example below, so we've got magnesium and hydrochloric acid makes magnesium chloride, and don't forget to add on the hydrogen. We have nitric acid, then we make a nitrate salt, and if we've got sulfuric acid, then we make a sulfate salt. So just remember, guys, depending on the type of acid, that will determine the type of salt. And remember, you need to know the formula of the acids, and you need to know the ion formulas of each salt. So chloride, Cl minus, nitrate N03 minus, and sulfate S042 minus, which we have covered before. Right, now all acids, now the reason we referred back to our reactivity series is that all acids contain hydrogen ions. So if we look at hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, so they all contain hydrogen, okay? And that's really, really important. Actually explains why our reactivity series of metals contain hydrogen, because this is such a vital reaction to know about. So essentially, when the metal reacts with the acid ionizes. Essentially, the ions separate. So if it's hydrochloric acid, the ions that come out would be hydrogen and a chloride. If it was sulfuric acid, we'd get sulfate ions and hydrogen ions, and if it's nitric acid, we'd get hydrogen ions and nitrate ions in the solution. Now, that's quite a key point, and we will get onto this in future lessons, but just something to know is that the concentration of hydrogen ions is directly correlated to the pH of the acid. Essentially, the higher the concentration of hydrogen ions, the more acidic the solution, or the lower its pH, okay? And we will get onto that towards the end of this topic. Now, essentially, this is a redox reaction. So we said that a salt is formed when the metal is more reactive than the hydrogen in the acid. So essentially, the metal displaces the hydrogen in the solution, and that would mean that the hydrogen ions, the H+ ions, are reduced, and the metal is oxidized when the salt is formed. Okay, so these reactions are redox reactions. So remember, oxidation is loss of electrons, so the metals would need to lose their outer shell electrons to form the salt, and as a result, the hydrogen ions would gain those electrons from the metal and become reduced. And we're going to go through a few examples now. So this is a very common example. You've probably even done it in class before. Hydrochloric acid plus magnesium. We usually put a strip of magnesium, and you can see lots of bubbles coming out in the test tube. That would be the hydrogen gas. And we form a magnesium chloride solution. So you should be able to, by now, be able to change the word equation into a chemical symbol equation with the state symbols and balance it accordingly. Now, we want to delve into how this is actually a redox reaction. So we'll start by looking at what happens to the magnesium. So in the reactant side, magnesium has no charge, but in order to form the salt, in order to bond to those chloride ions from the acid, it needs to lose 2 of its outer shell electrons. Remember, magnesium's in group 2, so the ion formed will be Mg2+. With the hydrogen, that each hydrogen in the acid has got a 2+, sorry, each hydrogen ion has a 1+ charge, but because we've got 2 hydrogen ions in this reaction, the overall charge will be 2+. When the acid reacts with the metal, the hydrogen ions are reduced and we form hydrogen gas. And as a result, we can say that those 2 electrons that magnesium gave off are given to the hydrogen ions, and they actually form a hydrogen molecule, which is actually a covalent molecule. If we look back to covalent bonding, hydrogen is a covalent molecule. There's a covalent bond that's formed once hydrogen ions get their electrons back. So this is half equation to show the reduction of hydrogen. So we'll just show you the half equation of magnesium on the next slide here. So magnesium, remember, lost those outer shell electrons to give to hydrogen, and therefore it was oxidized. Remember, we don't need to, well, if we combine the 2, let's do that now. Combine the 2 half equations, we get the ionic equations. Remember, we don't need to include the chloride ion because that's our spectator ion. Nothing changes with the chloride. It always has a -1 charge. Okay, excellent. So following that format of reduction, oxidation, and combining the 2 to get the ionic equation, can you please try this question? So we've got hydrochloric acid plus zinc, makes zinc chloride plus hydrogen. So first thing you need to do is write the balance symbol equation. Then please write the 2 half equations, combine them to get the ionic equation. So if you just pause the video now and try that. Right, let's go through it. So the first thing you need to check is that your balance symbol equation is correct. So you should have had 2 molecules of hydrochloric acid reacting with 1 molecule of zinc. That makes zinc chloride plus hydrogen. Just check that you've got that right. If you didn't, then you will need to review your half equations. So if you didn't get that correct, pause the video now and just check or retry the half equations. The rest of you, let's carry on. So we've got reduction and oxidation. Essentially, hydrogen, once again, actually in all of the cases, is always going to be reduced, the hydrogen ions, because they gain those electrons from the metal to form the hydrogen molecule. Zinc, in this case, has a charge of 2+, because if we look at the ratio of ions, so the ratio of chloride to zinc, each chloride has a charge of -1. Therefore, if we've got 2 chloride ions, we need an overall charge of +2 in our zinc. And by combining the 2 half equations, we form the ionic equation, pretty similar to the first example. Right, this time I've actually not completed the word equation. So if you use the table from before or your previous knowledge about what product or what salt will be formed, going back to our rule, firstly you need to finish the word equation, then write the balance symbol equation, then write the half equations and combine them to get the ionic equation. So let's pause the video and try this one. Okay, and let's go through it. So we've got sulfuric acid plus zinc will make zinc sulfate plus hydrogen. Remember the formula for sulfuric acid is H2SO4. Our half equation for the reduction of hydrogen is the same. We've got each hydrogen ion gains electrons from zinc to form a hydrogen molecule, and zinc is oxidized by losing 2 electrons in order to form zinc sulfate, and combining the two half equations gives you this. We do not need to include sulfate in the ionic equation or in any of our half equations. Sulfate remains unchanged on both sides. It's our spectator ion, hence not included in the ionic equation. Okay, great. Well done if you've got those correct. Something to think about. So, would copper react with hydrochloric acid? So just pause the video and think about that. Would copper react with hydrochloric acid? And I've put the reactivity series there as a reference. Okay, would copper react with hydrochloric acid? The answer is no. And because copper is less reactive than hydrogen, it will not be able to displace the hydrogen in the acid. Okay, so because it's not reactive enough, no reaction would occur, and the hydrogen ions will not be displaced, so you wouldn't form hydrogen gas or a salt because it's less reactive. Okay, excellent. Right, the next few lessons we'll be looking at the reactions of acids with bases. So we've just looked at acids reacting with metals to make a salt. We're then going to look at the reactions of acids with bases.